Hello, today we're going to talk about the readings by two very different kinds of thinkers. Paulo Freire is a Brazilian Marxist educator who spent his whole career and his whole life trying to educate peasants into social responsibility. And Richard Feynman was one of the great physics geniuses of the last 50 years or so, Nobel Prize winner in physics. But the little vignette I had you read from Feynman comes from his time in Brazil. So both Freire and Feynman are talking about a Brazilian education system in the 1950s. And that's crucial because it gives us some commonalities to what they have to say and is going to let us ask, I think at the end, some crucial questions, which I'm going to ask you to answer on the bulletin board. Here's a picture of Paulo Freire. Notice the cool hair and the cool beard, kind of like a skinny Santa Claus? Well, the book that he wrote, Pedagogy of the Oppressed, is one of the most famous treatises on education written in the 20th century. He is from Brazil, and as I said, he is a Marxist, which isn't quite the same as a communist in the Soviet Union, but he was a Marxist who believed that education should empower the people of the lowest classes. And at this time in his career, these were the peasants in Brazil. And he invented this notion, which he calls the banking concept of education, which applies to a lot of the education that I've had in my life and a lot of the education that still happens in Brazil and in the United States and all over the world. And banking concept is because the teacher makes deposits of knowledge in the student's brain, and when the students have enough knowledge, then they can go out in the world and spend the knowledge that has been deposited. And this, Freire says, sets up a dynamic where the teacher has all of the power, the student has none of the power. Look at some of the ways that he describes banking education. The teacher teaches, the students are taught. The teacher knows everything and the student knows nothing. The teacher thinks and the students are thought about. The teacher talks and the students listen meekly, and so on and so forth. And you can read those yourself. But this is a model of education where all authority resides in the teacher, and all the teacher is doing is sort of depositing knowledge in the students. I call it the gas station model of education. The students drive up with their empty tanks, and the teacher fills those tanks with knowledge. So how well does the banking concept of education do in teaching critical things to students? Turns out not very well at all. And this is what Richard Feynman discovered when he went to Brazil as part of a Fulbright lectureship in the 50s, about the same time that Freire was doing a lot of his work. And he discovered that the students in Brazil knew a lot of things. They had memorized a lot of answers, but they didn't know how to do a lot of things. And this is what he discusses in Ao Americano Outra Vez, that these students, he could ask them questions about scientific formulas, and they knew the answers better than any American students did. But when he asked them to apply the formulas or to use them in anything other than a rote memory context, they weren't able to do it. And this is largely because that model of education, the banking model of education, is very good at committing students to memorize facts. It's not very good at getting students to solve problems. I want you to just listen here for a second as Feynman himself describes this idea of solving problems, which is, in his mind, the central purpose of education, is to teach people how to solve problems. So how well does the banking concept of education?
Monday, when they were all back to work, all the kids were playing in the field. And one kid said to me, see that bird? What kind of a bird is that? And I said, I haven't the slightest idea what kind of a bird it is. He says, it's a brown-throated thrush or something. He says, your father doesn't tell you anything. But it was the opposite. My father had taught me, looking at a bird, he says, do you know what that bird is? It's a brown-throated thrush. But in Portuguese, it's a hontarapero. In Italian, a chutera piquita. He says in Chinese, it's a chongmongtong. In Japanese, patara tokodacha, etc. He says, now they've know all the languages you want to know what the name of that bird is. And when you're finished with all that, he says, you'll know absolutely nothing whatever about the bird. You only know about humans in different places and what they call the bird. Now, he says, let's look at the bird and what it's doing. He had taught me to notice things, and one day when I was playing with what we call an express wagon, which is a little wagon which has a railing around it for children to play with that they can pull around. It had a ball in it. I remember this. It had a ball in it. And I pulled the wagon, and I noticed something about the way the ball moved. So I went to my father, and I said, say, Pop, I noticed something. When I pull the wagon, the ball rolls to the back of the wagon. It rushes to the back of the wagon. And when I'm pulling along and I suddenly stop, the ball rolls to the front of the wagon. I said, why is that? And he said, that, he says, nobody knows. He said, the general principle is that things that are moving try to keep on moving, and things that are standing still tend to stand still unless you push on them hard. And he says, this tendency is called inertia, but nobody knows why it's true. Now that's a deep understanding. He doesn't give me a name. He knew the difference between knowing the name of something and knowing something.
The difference between knowing the name of a bird and knowing a bird, or the difference between knowing the name of a scientific principle and knowing how to apply it, is the difference between being able to recall facts and being able to solve a problem. Look at our cartoon here, pivotal moments in teeter-totter technology, knowing the name of the rock, knowing that something is a lever, knowing about leverage. Those are very different things. To solve the problem, you don't need to know the names of things. You need to know things. This was Feynman's crusade throughout his life. My most favorite of his books is called simply The Pleasure of Finding Things Out. And in all of his teaching, and he was one of the most famous teachers of quantum mechanics of the 20th century, in all of his lectures and all of his writings, he highlighted the importance of understanding things well enough to use them to solve problems. So here are the two questions I want you to answer on the discussion boards, and I'd like you to also discuss with each other. I'll try to discuss things and ask questions on your posts, but ask each other questions and comment on each other's posts too. That's part of what the discussion boards are supposed to do. Question 1. Do you believe that your education has prepared you to solve complex problems, or do you believe that your education has been primarily concerned with learning facts? In other words, do you think your teachers all the way back to kindergarten have primarily used the banking model or the banking concept of education where they've expected you to sit quietly and learn facts? Or have you been prepared to solve problems? And I don't know. I went to school in the 70s and it was one way, but I know a lot of you have been to school in different times in different places and have had different educational experiences. Second, however you answer the first question, I want to know if Freire is correct and the traditional methods of education, of teaching and learning are educationally unsound, what should teachers do? How can educators prepare students with the skills necessary to solve complex and difficult problems in their lives? And this is just, I want your opinion on how education should work in the best of all possible worlds. What should teachers do all day in class? What should college teachers do? How can we do a better job with what's most important in education?